Okay, so we're going to go to example 1, and all we have to do is just say, is it true or false, okay? Now, very important, right here, we are given that it's a parallelogram, all right, which means that the 7 properties that we just discussed up top are true about this parallelogram, okay? So all we have to say is true or false. All right, so let's start with the first one. So do we know that AB has to be congruent to DC? Well, this one is true because we know that opposite sides have to be congruent. All right, I'm going to erase this now. Next one, do we know that AB is congruent to BC? Well, those two sides are consecutive, all right? And we don't have a theorem that says that consecutive sides have to be congruent, so this one is false. Okay. All right, next one. Do we know that AE is congruent to EC? This has to be true because diagonals bisect each other, which means that that intersection point E has to be the midpoint of each of those diagonals, which means that it splits it into congruent segments. Okay? All right, next one. Do we know that angle 3 is congruent to angle 2? Now, this one's a little bit trickier, but I want to highlight something so that you guys can kind of look at what I'm looking at first, okay? What do we know about DC and AB? Well, we know that they're congruent, but what else do we know about them? We know that they have to be parallel because it's a parallelogram, right? Now, I'm going to highlight this side right here, this segment right here, and this segment right here of AC is technically the transversal with those parallel lines, which means what about angle 3 and angle 2? What type of angles are they? Well, they're alternate interior angles, and if the segments are parallel, then those two alternate interior angles have to be congruent, which means that this statement is true as well. Okay, next one. Angle ADC, so this full angle right here, okay, is congruent to angle ABC, which is this angle right here. Is that true or false? That is true, because we know that opposite angles have to be congruent. Okay? All right, next one. Do we know that angle, I'm going to pick a different color so it's a little bit easier to see, ADC again, is congruent to angle CBA? Well, that's kind of silly because it's just the same type of question, all right, that we just talked about. This is also true. ADC, CBA, just making sure that I did that one correctly. This is also true because of opposite angles have to be congruent. All right, next one, DB. So the length of DB is twice of DE. This is also true, all right? And that's because, once again, diagonals bisect each other, all right, which means that this segment has to be congruent to this segment. So if you added up DE plus EB, all right, that would have to equal that would have to equal all of DB, all right? And since DE is equal to EB, all right, DB is double that. All right, last one, triangle ADB is congruent to triangle CBD, and this is also true because we know that the diagonals split the parallelogram into two congruent triangles. Okay. All right, so the next example, we have to find the missing variables, okay? So let's start with finding x. So let's identify x first, all right? So x right here is the length of QT. And I'm going to look at QT and RS, all right? I know that because it's a parallelogram, all right, that the opposite sides have to be congruent. So I'm going to set 5x equal to 27. And then when I divide that out, I get 5.4. So x is equal to 5.4. All right, for the next one, and I think this one's kind of hard to figure out what expression goes with what, all right? So I'm going to kind of guide you guys through. So 2y is actually representing this segment right here, all right? While y plus 4 is representing this segment right here, okay? And so we know that diagonals bisect each other inside of a parallelogram, all right, which means that this intersection point P has to be the midpoint, which means that this segment has to be congruent to this segment. So I'm going to set 2y minus 5 equal to y plus 4. And I'm going to solve. I'm going to subtract the y, add the 5. Y is equal to 9. All right, last one. We need to solve for z, okay? So what z is representing is this angle right here, okay? And what we're going to do is we're going to do that same kind of idea where we're going to remember that these two sides right here, QR and ST, have to be parallel, and that QS, all right, is my transversal, which means that this 3Z and the 33 are alternate interior angles. And because we know that the lines are parallel, we know that alternate interior angles have to be congruent. So we're going to set 3Z equal to 33, and you're going to get Z is equal to 11. Okay, so on the U-Try, I think you guys can probably do these on your own, okay? I'm going to give you guys the answers just as we are going through here. Sorry, I'm pulling up my answer key real quick. Okay, so for the first one, all right, you can get A is equal to 7, and then B is equal to 11. And if you don't know how to do these, make sure that you guys look at my answer key. All right, all my work is shown. All right, for the next one, you're going to get X is equal to, I got 43.5, and Y is equal to 49.5. Okay, so just the starting point of this, you're going to want to do x minus 5 plus 2x plus 11 equals 180. And then when you find x, plug that into this expression of h and set it equal to 2y. Okay, just a heads up. All right, so I'm going to pause here, and I'm going to go and then start with example 4, and we do start getting into some proofs from there, okay?